Good evening, guys. So today we'll discuss the second exercise. How is that? The next, so before that, is there any doubt from yesterday's discussion? Any point that is not clear? Any doubt between direction cosine and direction ratio?
No doubt, sir.
Yes, sir.
Okay. So listen. We will be seeing the equation of line and space, right? So as I mentioned previously, we have studied the equation of lines in 2 dimensions in class 11. Now we'll study about the vector and Cartesian equations of line and space. So this is what we are going to do. First is we are going to see the Cartesian form, then we will see the vector form or the vice versa. So you understand what is Cartesian form, right? If I write ax plus by plus c is equal to 0, this is called as Cartesian form because I'm using the variables from the Cartesian coordinates. Whereas if I use something like this, r vector minus a vector dot b vector is equal to 0, then I'm using the vector equation. So this is called as the vector equation. Okay. So remember one thing. Last year, you remember, you have many forms of line. Y is equal to mx, y is equal to mx plus c. Then you have x cos alpha plus y sin alpha is equal to p. Then you have y minus y1 is equal to m into x minus x1. You guys remember that there are different forms of line that are available. Right? If you remember, that is enough. So there are different forms of lines that are available, where I can say that if I want to write the equation y is equal to mx, I need to know that the line is passing through the origin and its slope is m. Okay. If I have to write y is equal to mx plus c, then I need to know the slope of the line and the y-intercept. Similarly, if I have to know x cos alpha plus y sin alpha is equal to p, then I need to know the angle which the perpendicular is making and all those things. So similarly, there are certain requirements. In a similar way, if you want to write the equation of line and space, then there are two ways to write it. One is, if you know the point through which the line passes, and if you know the direction in which the line is aligned to, then you will be able to write the equation of line. That is one requirement. Second is, if you know both the points through which the line is passing. If you know these two parameters, you can write the line. Are you able to understand what I'm trying to say? So if you have to write the equation of line and space, it's not a very big thing. One is, you will be able to write that particular equation if you know the point through which, if you know one of the points on the line, and if you know the direction of that line. Direction means the direction cosines or direction ratios of that line. Or I should know minimum 2 points on that line. So if I know both the points on the line, I don't need the direction. That is the meaning. So having said this, can we get started? Right. So first thing is equation of a line passing through a given point and parallel to a given vector. When I say parallel to a given vector, then what is the meaning of it? When I say a line is parallel to the given vector, what is the meaning of it?
The line doesn't intersect.
Sorry, I didn't understand. So
The
this is a line.
These two lines will never intersect if you extend in any way.
Okay, that is right. That is right. But if you look at the basic thing of it, no, I'm asked to write the equation of a line. The line is this thing. So I will be able to write the equation of this line, provided I know one of the points on the line, and that point is A. Okay. So through a given point, and the given point is A, and it is parallel to given vector B means whenever, remember, when you talk about parallel in the case of vectors, more than the concept of intersection, right? We are concerned about the proportional values in the sense, yesterday I told you, right, how you prove that two lines are collinear. You remember this?
The
Collinear.
directional ratio should be proportional.
Yes, that is the meaning actually. You understand? So when they say that you know a line which is parallel to a given vector, indirectly you are trying to say that you know the direction cosines of that line. Are you able to understand what I'm trying to say? Indirectly, what am I saying? I know the direction cosines of that line, and I know the direction ratios in proportion of that line. Okay, only if you know these 2 points, you will be able to answer this. Listen to this very, very, very carefully. Okay, I'm giving you a step-by-step procedure of how to think. That is more important in this chapter. So I have a line, and this line is in what? Is it in a 2-dimensional plane or a space? Space. So on this, what is given to us? I know a point. When I say I know a point, then I know the coordinates of that point, x1, y1, and z1. Or, so this is, so try to understand, we are talking about 2 things here. x1, y1, z1 is a parameter associated with respect to the Cartesian format. Whereas, if I know x1, y1, z1, according to the basics of vector algebra, I can say that I know the position vector of this line also, which is a vector. Are you able to understand these 2 points?
Yes, sir.
Right? Now, what did they say? We know that it is parallel to vector b bar. When it is parallel to vector b bar, let me say b vector is equal to b1 I cap plus b2 j cap plus b3 k cap. Now comes an important question that I'm going to ask you. Listen to this carefully. The coefficients b1, b2, and b3 are there, right? What are they? The coefficients b1, b2, and b3, are they the direction cosines or direction ratios? If you have this clarity, it is more than sufficient. Think and tell me. B1, B2, and B3 are the coefficients of I cap, J cap, and K cap. Are they the direction cosines or direction ratios?
Ratio, no?
Is it a guess or a sure shot answer?
Guess.
Guess, but your guess is right. They're the direction ratios. Okay. So remember, if any vector is given to you, any vector for that matter, unless it is a unit vector. So try to understand, if B vector is given to you, B1 I cap plus B2 J cap plus B3 K cap, the coefficients of any vector apart from a unit vector are the direction ratios. I hope everybody is making a note of this point. Please write it down. The coefficients of I cap, J cap, and K cap for any vector other than which one? Other than the unit vector are direction ratios. Whereas if I give you B cap is equal to B1 I cap plus B2 J cap plus B3 K cap, then in this case, what is B1, B2, B3?
Directional cosine.
They are direction cosines. Why are they direction cosines? Because if you take magnitude of B cap, what will you get? Root of B1 square plus B2 square, B3 square, you will get it as 1. When you square on both the sides, B1 square plus B2 square plus B3 square is still 1. And which one will satisfy this particular mathematical equation? It is only direction
Cosine.
cosines. Are you people understanding what I'm trying to say? So next time onwards,
Yes.
you need not break your head at all. A general vector, direction ratio. Unit vector, direction cosines. That's it. So if you know now what I'm trying to say is, You have a line and you have a point on that line. And you know that this line is parallel to whom? This line is parallel to a given vector. When the concept of parallelism comes, I told you what is the condition. What is the condition? If this vector is b bar, then if I take a random point p, which is called as the locus point, and I call this as r, okay, where the coordinates of this point is x, y, z. This is a general point. Try to understand. Then AP will form a vector. Can I call AP vector?
Yes, sir.
Right. What will be the direct? What will be the? So how can I write AP vector in terms of B vector? Tell me.
OA
can I write
vector minus OP vector.
Can I say AP vector is lambda times B vector? Why? According to the knowledge of vector algebra, if two vectors are parallel to each other, then they should be the same proportion, correct? So if A1
Yes, sir.
and A2 are parallel, can I say A1 is equal to lambda times A2? We have solved many problems based on this. Similarly, AP vector is parallel to B vector. So AP vector will be lambda times B vector. That lambda can be anything. I'm not concerned what it is. It can be any scalar value. It can be positive or negative. I'm not concerned about it. Does this make sense or not? So what is the whole story behind this derivation? First is you have a line, and now try to read what I'm trying to say. If you know the given point on that line, and if you know the given direction, when I say given direction, indirectly what are they trying to say? If you know if you know the direction ratios of the line itself, or if you know the direction ratios of the line to which this line is parallel to. That is why they gave the word parallel to the given vector b bar. I could have directly given you formula, but you will not understand it. Now you will be confident when I derive it. See, it is only one step, but these basics are important. Are you clear with this? Please give me a confirmation. Every step, is it clear?
Yes, sir.
Right? That's more important.
I have a doubt, sir, actually, in the
Tell me.
textbook.
Tell me.
Could you show the textbook for a minute, sir?
Sure.
So here we are representing AP vector as lambda B vector, right? Just because we know
AP
what
vector
B
is lambda B vector. AP vector. You understood why it is lambda B vector, no?
Yes, sir, because proportional. So
Because they are parallel to each other. When two vectors are parallel, one vector is lambda times the other vector. That is the logic.
yes, sir, understood that. Sir.
Okay. So A is the given point, P is the general point. So whenever you want to write the equation of line, right, you always take a general point. General point is taken as x, y, z in terms of coordinates, and it is taken as r vector in terms of vector. Okay, it is not r cap, it is r vector. Right, having said all these things, now I'm going to draw a free body diagram of OAP. Okay, OAP. So what is OA vector? It is A vector. OP vector is R vector. What is AP vector? It is lambda times B vector. Correct? Now you're done. What is that you're able to see on the paper? What is it actually?
A triangle, sir.
It's a triangle. Apply triangle of addition of vectors and tell me. A vector plus
Lambda B vector equal to R.
Lambda B vector is equal to R vector.
Is this not the equation you have learned? If you
Yes,
already
sir.
learned, now you understood how it does. Not a big thing. It's a simple logic. So R vector is equal to A vector plus lambda times B vector. Then what do you call this as? This is called as the vector equation of the line. Okay. Now, if I have to write R vector, can I write it as xi cap plus yj cap plus zk cap? And if I have to write a vector, can I write it as x1 I cap plus x2 j cap plus x3 k cap, and b vector can I write it as ai cap plus bj cap plus ck cap. Can I write it like this? Yeah. Where x, y, z are what? X, y, z are the direction. Now tell me. Let me see how much you
Ratio.
remember. They are the direction ratios of whom? They are the direction ratio of whom? Of r vector. X1, X2, and X3 are the direction ratio of a vector. A, B, C are the direction ratios of B vector. If I take this and substitute it here, then what will I get? X1 I cap plus, I'll make it as X1, Y1 and Z1. Because those are the coordinates, right? X1, Y1, Z1 are the coordinates. So X1 I cap plus Y1 J cap plus Z1 K cap plus lambda times AI cap plus BJ cap plus CK cap is equal to R vector is what? XI cap plus YJ cap plus ZK cap. Okay. Now we will take this whole thing to the right hand side. Then I can say X minus X1 I cap plus Y minus Y1 J cap plus Z minus Z1 K cap is equal to lambda times AI cap plus BJ cap plus CK cap. Then what I can say, x minus x1 divided by a will be equal to y minus y1 divided by b will be equal to z minus z1 divided by c is a constant lambda. So this is what? This is the Cartesian equation or Cartesian form of a line in, this is the Cartesian form of a line when a point and direction is known. Done. I see, I'm sure you would have learned all these things. But the concern I have is understanding why it has come. Right? So if you give me a confirmation, I'll proceed to the next step. I mean, next portion. You're making a note?
Yes, sir. Yes, sir.
Yeah, please write it.
Done, sir.
Okay. Now listen to this carefully. Okay. If I know the 2 points through which the line is passing, then I can write the line, the equation. Okay. So second case is equation of line when 2 points are given. So if I take this as x1 and x2, I take this as x1, y1, z1, and if I take this as x2, y2, z2, 2 points are given to you and you're asked to write the equation of line. So whenever you need to write any equation in this world, you need to take a general point P as x, y, z. So if I call this point as A, where x1, y1, and z1, and if I call this point as B, then this point is P, then this is A vector, this is B vector, and this is R vector. Clear? Now, what can I say about the points A, B, and P? They are What can I say about the points A, B, and P? I asked a simple question. A, B, and P are dash. Guys, I'm not able to shout. What is it? How are they? A, B, and P, where are they
They're
lying?
collinear, sir.
That is what I'm asking. A, B, and P are collinear. And yesterday I told you what condition for collinearity? DRs are in dash.
Proportion.
Yeah, DCs are dash. DRs are in proportion and DCs are same. But generally we don't solve any problem using the direction cosine. We go with direction ratios only. So tell me, what is the direction ratio of AB? If you know 2 points, how will you write the direction ratio of the particular line? It is x2 minus x1, y2 minus y1, and z2 minus z1. So what is the direction ratio of AP? X minus x1, y minus y1, and z minus z1. Correct? Any doubt?
No, sir.
Right. Now I told direction ratios are in proportion. So direction ratio of AP is equal to lambda times direction ratios of AB. Okay, I'll make it AB here. I can write AP here. Accepted. I didn't use anything. I used the property of collinearity. That's it. Okay. Then direction ratio of AB is x2 minus x1 is equal to lambda times x minus x1. Similarly, y2 minus y1 is equal to lambda times y minus y1. z2 minus z1 is equal to lambda times z minus z1. Okay. Then can I write x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by z2 minus z1 is equal to z minus z1 divided by z2 minus z1 is equal to 1 by lambda. Right?
So where do we use this formula actually, sir?
When 2 points are given. This is the card. You have not seen this at all. Huh?
I've seen it, sir, but that 1 by lambda, what would we give it in?
1 by lambda you don't need. 1 by lambda you don't need it. This is the equation. But why it has
Okay,
come,
sir.
it is because it is 1 by lambda. That is the reason. I'm not using this lambda at all. We don't use it. I'm
Yes,
saying
understood.
these three are equal because they all are equal to 1 by lambda. That is what I think it's. Put that.
So also it's y minus y1 by y2 minus y1, right, sir?
I made a mistake. This is y2 minus y1. Is equal to z minus z1 divided by z2 minus z1. Right. Now see, the points are in such a way that this is A, B, and P. The position vector of A is A bar, position vector of B is B bar, and position vector of P is R bar. Okay. So what is AB vector? AB vector, from the concept of position vectors, we know that it is B vector minus A vector. What is AP vector? It is R vector minus A vector. Correct?
Yes, sir.
So what I can do is, since AP vector is equal to lambda times AP vector, I can write R vector minus A vector is equal to lambda times B vector minus A vector. So this will be the vector form of the line. In a similar way, do you think this is the only formula for this? Will you be able to derive an alternate formula also for this? Why am I always taking only AB and AP? Why can't I take BP? Can I say AP vector is equal to some mu times BP vector? Can't I write it like this? Can I or not? Yes. So R vector minus A vector can be mu times R vector minus B vector. When you do this, right, you will get the same answer. But generally, what I suggest is go with the textbook, because you might lose marks when your teachers are expecting something. But for the sake of knowledge, I have to tell you that there are multiple equations that are possible. So most important of all that we need to understand is the logic behind why that equation has come. Is it clear? Is it clear? That is more important.
Yes, it's clear, sir.
It's clear, right? That's good. So even if you forget exam all, you will be able to derive it. Yeah. Now, having this knowledge, can we try out 2 or 3 problems?
Yes, sir.
Right. Find the vector equation for the line passing through the point minus 0, 2 and 3, 4, 6. They're asking the vector equation. So if I take this point as A, then what is A vector? Minus I cap plus 0 j cap plus 2 k cap. Accepted? Nothing. Just put an I cap, j cap, k cap for the Cartesian products, because it is a point with respect to origin. Then what about B vector, guys? It will be 3i cap plus 4j cap plus 6k cap. Now what will be the vector equation? R vector will be equal to A vector plus lambda times B vector minus A vector. So R vector is equal to A vector is minus I cap plus 2k cap plus lambda times 4i cap plus 4j cap plus 8k cap. This is the vector equation. Oh, plus 4k cap, sorry. If there is anyone having a doubt of why I wrote it like this, please get it clarified. I did nothing but using the formula. Nothing outside that I thought of.
Sir, I have a doubt.
Please tell.
Why did you write it as B vector minus A vector?
You can write A vector minus B vector also. It's still right. Because I took AB vector here. So look at the formula I wrote here. I wrote it as B vector minus A vector. So R vector is equal to A vector plus lambda times B vector minus A vector. If you want to write this as A vector minus B vector, you are absolutely free to do so. Only thing is, instead of lambda, put some mu or something. Because why I am saying you are free to do so is because we don't know the value of lambda. Unless you know the value of lambda, you cannot write the absolute equation. This is a general equation that you have to write. Are you able to understand?
Yes, sir.
But I repeat, for the sake of your safety, I'm not sure how your teachers will expect or what is expected in both. If they go with the answer key, then they will look at this like a formula only. They will not think of logic and all. Okay, so go with B vector minus A vector. But to answer your question, as a generic part, you can write it as A vector minus B vector also, but don't do it. Okay. Next is the Cartesian form of the line is given here. So that is x plus 3 by 2 is equal to y minus 5 by 4 is equal to z plus 6 by 2. If I call this as some lambda, then you need to write the vector equation. So what is x equal to? Rohan, you asked me, where will you use that 1 by lambda, sir?
Yes,
So
sir.
instead of 1 by lambda, I wrote it as lambda. So then x will be equal to how much? 2 times lambda, correct?
2
Observe
times
this.
lambda minus 3. Sir.
Minus 3. Upper y another.
4 lambda
4
plus
times
5.
lambda plus 5. Z will be
2
2
lambda
times lambda minus 6, correct? But this x, y, and z are the coefficients of R vector. So they ask the vector form. R vector is equal to how much? Xi cap plus yj cap plus zk cap. So take and substitute that value. 2 lambda minus 3 I cap plus 4 lambda plus 5 j cap plus 2 lambda minus 6 k cap. So this is the vector equation. Are you able to understand what is the difference between this and this? Generally, when they present it, right, they try to separate that lambda and write it. So to put it in simple terms, I can write it as minus 3 I cap plus 5 j cap minus 6 k cap plus collect all the lambda terms. Lambda into 2 I cap plus 4 j cap plus 2 k cap. Am I clear, guys?
Yes, sir.
Okay. So there is one more thing also that we need to do. Find the vector equation of the line passing through the point 5, 2, minus 4 and which is parallel to this. So when you know a point R vector is equal to A vector is a point lambda times B vector, where B vector is the one to which the line is parallel to. Okay. Just write it and collect all the data. You will get the answer. So vector form is R vector is equal to 5 I cap plus 2 j cap minus 4 k cap plus lambda times B vector is 3 I cap plus 2 j cap minus 8 k cap. Then what will be the Cartesian form? Cartesian form will be x minus 5 by 3 is equal to y minus 2 by 2 is equal to z plus 4 divided by minus 8. Okay. Done. Now, having all this knowledge, we are going to see how to find the angle between two lines. Okay. Wait. So first let us see the requirements. Okay. When you need to find the angle between two lines, what is the data that you need to know is you need to know the direction ratios of both lines. Okay. So let's say the direction ratio of this line is A1, B1, C1. A1, B1, C1. And the direction ratio of the second line is A2, B2, C2. Okay. Then can I say so this is L1. If this is A1, B1, C1, can I say then this vector will be A1 I cap plus B1 J cap plus C1 K cap? Accepted. Can I directly write this line as A1 I cap plus B1 J C1 K cap? And I will take the other line L2 and write it as A2 I cap plus B2 J cap plus C2 K cap. Can I do this? And if I take the angle between the both as theta, when you know two vectors, then what is cos of the angle between those two vectors? Is it not A vector dot B vector divided by magnitude of A vector into magnitude of B vector? So what is A vector dot B vector? It is A1 A2 plus B1 B2 plus C1 C2 the whole divided by root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square. Accepted?
Yes, sir.
That's it. So this is the formula. Means if you know the direction ratios of two lines, so direction ratios can either be known directly or from the line to which these lines are parallel to. Okay, sometimes what they will do is they'll give you something like this. R vector is equal to, or R1 vector is equal to A1 vector plus lambda times B1 vector. R2 vector is equal to A2 vector plus lambda times B2 vector. Okay. If they give you this, the general form of a line, like how you say AX plus BY plus C is equal to 0, the general form of a line in the two-dimensional coordinate. In the form of vector coordinates, these are the general equations of line. If these two lines are given to you, okay, answer my question clearly. Then out of A1 and B1, who will decide the direction ratios of that particular line? Guys, very simple, okay? If you see R vector is equal to A vector plus lambda times B vector, what is your conclusion? This A vector is what? A vector is the point through which the line is passing. Correct? What is B1 vector? B1 vector is the vector to which the line is parallel to. So out of A1 and B1, who is deciding the direction ratios of the given line R1?
B1 vector.
Correct. Then I can say cos theta is equal to B1 vector dot B2 vector divided by magnitude of B1 vector into magnitude of B2 vector. Are you able to understand? So if the general form of the line is given to you and you're asked to find the angle between those two lines, you just take the dot product between B1 and B2 and divide them with the product of their individual magnitudes. Okay, let me take an example and explain this. I'm not going to get into these complicated structures. It is very difficult. Let me take an example and then explain it. Find the angle between the pair of lines given by this thing. So this is the general form. R vector is equal to, this is one vector plus lambda times another vector. So what is this, guys? This is of the form A1 vector plus lambda times B1 vector. Correct? Second line is of the form A2 vector plus mu times B2 vector. Mu is used because I told you lambda and mu are, they are different parameters. Now, what is going to be cos theta? I want you guys to tell me. Cos theta will be equal to how much? Magnitude of B1 vector dot B2 vector divided by magnitude of B1 vector into B2 vector. So what is B1 dot B2? 3 plus 4 plus 12, the whole divided by square root of 4 plus 4 plus 1, 9. So that will be 3 into this one be square root of 9 plus 4, that is 9 plus 4, 13. 13 plus 36 is how much? 49, that will be 7. So magnitude of this 12 plus 4, 16, 16 plus 3, 19 divided by 21. So theta will be equal to cos inverse of 19 divided by 21. That is the angle between these two lines. Did you understand, guys?
Yes, sir.
Yes, sir.
It's a very simple thing. Now, find the angle between the pair of lines given like this. So in the previous case, they gave you in the vector form. In this case, they are given in the Cartesian form. So to put it in simple terms, if you need to find cos theta, you only need the direction ratios of that particular line. Here, when they give it in Cartesian form, what do these denominators represent? What do those denominators represent? So you're writing something like this, no? X minus x1 divided by A is equal to y minus y1 divided by B is equal to z minus z1 divided by C, no? What do those A, B, C represent?
Ratio.
If you know the direction ratio, then if you know the direction ratio, if vectors are given, you are using the vector formula. If direction ratios are given, I already derived the formula for you. A1, A2, that is 3 into 1 plus 5 into 1 plus 4 into 2, the whole divided by square root of 3 square plus 5 square plus 4 square. How much is that? 9 plus 25 is 34. 34 plus 16 is 50. So root 50 into root of 1 square plus 1 square plus 1 plus 1 plus 4. Root 6. Okay. So that 50 you can write it as 5 root 2 and all those things. Then you will get cos theta is equal to 8 root 3 divided by 15, and theta will be equal to cos inverse of 8 root 3 divided by 15. Okay. So what did we see? We already saw how to write the equation of lines, provided two conditions are given. Then we saw if the line equations are already given to you, how to find the angle between those two lines in terms of cos theta. Then there is something that you need to understand, that if the lines are perpendicular, then A1, A2 plus B1, B2 plus C1, C2 is 0. Why is it so? Why is it so? Because if the lines are perpendicular, cos theta will be equal to 0. When cos theta is 0, the numerator is 0. That's it. Correct? Similarly, if the lines are parallel, then what I can say about the ratio of the direction difference? Then what can I say about the connection between the direction ratios? The direction ratios are in the same proportion, right? So I've been telling the same story again and again. Now the next question is, how will you find the shortest distance between two lines? Okay. For that, you will see something like this. First is, you need to find the distance between two skew lines. So what are skew lines? Can someone tell me what are skew lines from the knowledge that you have?
So skew lines are lines which are not parallel or proportional, sir.
Skew lines are those lines which are not parallel
Or
and
proportional.
not proportional. Skew lines are those lines which are not parallel, at the same time don't intersect also. It's contradicting, no? Is it not contradicting? What they say, skew lines are those lines which are not parallel. At the same time, they don't intersect also. How is it possible? In our lower grades, they told if there are two lines which are parallel, they will start intersecting. No? But what is the difference? What is the important point we need to focus upon? When two lines are not parallel and they will intersect only if they are in the
Same plane.
only if they are in a plane, in two-dimensional system that is followed. Whereas here we are not dealing with two-dimensional system, we are dealing with three-dimensional system. Let me show you an example. Okay, listen, observe this. You're able to see me, right? So one line is like this. See, in a two-dimensional plane, if these two are there, no, now you are able to see something like this, they are parallel. Whereas if they become something like this, there is a possibility for them to intersect. But this is one line, and this is another line, which is like this. Observe. This is one line, this is another line, this is in this plane, this is in this plane. I cannot say that these two lines are parallel, but at the same time, they will never intersect also. Then these kind of lines are what are called as skew lines.
Yes, understood.
Understood? So that is the meaning. Now our job is to find the distance between these two skew lines. Okay. See, for this one alone, I'm not getting into too much of derivation because it might confuse you. I'll directly go with the formula. Okay. So let me say R1, there are two skew lines given to you. Okay, L1 and L2 are two skew lines of the form. A1 vector plus lambda times B1 vector and A2 vector plus mu times B2 vector. If these two skew lines are given, then the distance between these two skew lines is given as the cross product of B1 and B2 vector dot the difference of A2 vector minus A1 vector divided by the cross product of B1 vector cross product of B1 and B2. So the distance is this one, magnitude of, why magnitude? Because distance can't be negative. B1 vector cross B2 vector, and you do the dot product of this with A2 minus A1 and divide it with the cross product, divide it with the magnitude of cross product of B1 and B2. This is what you're supposed to do. Okay.
So I have a doubt.
Please tell me.
So sir, the question they mention at skew lines, sir. Or we have to find
They'll
out
not,
the
they'll not
skew
mention
lines.
it. You have to see and find it out. How to find out, I'll tell you.
Okay, sir.
See, Cartesian form I'm not explaining because if suppose they give you in the Cartesian form, I would suggest you to convert it to vector form. That will take one extra step and then apply this form so that you're not confused with two different things. Because this formula is little tedious. Right? So what did I say? When they give you the lines in the Cartesian form, convert it to vector form and then use this formula. Okay. But for the sake of safety purpose, learn this formula and have it. If they suppose they ask you, write down the formula for shortest distance between the lines in the Cartesian form, then you need to know that. Okay. But I will not suggest you to apply it. So I'm not saying that you ignore it completely, learn it. And from my experience, I have not seen anybody asking you to write a formula, but we don't know how the patterns are coming. Just for safer side, learn this. Okay. Now, you asked me, no, distance between parallel lines. Rohan, you got the answer here. R vector is equal to A1 vector plus lambda times B vector. R vector is equal to A2 vector plus mu times B vector. What is that you're able to understand? What is the difference between skew lines and this one?
The proportionality numbers, sir.
No, look at the second term, no?
Yes, sir. Lambda and mu.
No, it is B vector and B vector. Whereas in the case of skew lines, what happened? It was B1 vector and B2 vector. Means B1 and B2 are different. Whereas if B1 and B2 are same, or if they're the same proportion, then they become parallel lines. Okay. When they are parallel lines, the formula is going to be something like this. It is B vector plus A2 vector minus A1 vector divided by B vector. Magnitude of B vector. Okay. If it is lines, what will you have? You will have B1 cross B2 dot A2 minus A1 divided by magnitude of B1 cross B2. Whereas when you talk about parallel lines, you will not have B1 cross B2. You will have only one vector, that is B vector. And here it becomes cross product. So B cross A2 minus A1. Whereas in the case of skew lines, B1 cross B2 dot A2 minus A1. These are the only two differences you need to make a note of. Because if I start this derivation, right, I have to explain about the vector products and taking the unit vector and then again going for the projection, it will confuse you. Let's not get into those details. Okay. Shall we start doing some problems?
Yes, sir.
Okay. So example 11. Find the shortest distance between the lines L1 and L2 whose vector equations are R vector is equal to I plus J plus lambda times 2I cap minus J cap plus K cap, and R vector is equal to 2I cap plus J cap minus K cap plus mu times this value. Tell me whether these two are skew lines or parallel lines.
Skew lines, sir.
Q lines.
Yes, the skew lines because they are B1 vector and B2 vector. Then what is the formula? magnitude of B1 vector cross B2 vector. First, we need to find this. Then dot of A2 vector minus A1 vector and divide it with the magnitude of B1 vector cross B2 vector and take the magnitude of this whole thing. First, let us find what is B1 vector cross B2 vector. Do it fast and tell me.
So root 59, sir.
You are talking about the magnitude. I asked only what is B1 vector cross B2.
3
You
I
get a
cap
vector.
minus j cap minus 7 k cap, sir.
Okay, so this is right only. Okay. Then the magnitude of this is root 59. Okay, what is A2 vector minus A1 vector? I cap minus K cap.
Yes, sir.
Now, if you do the dot product between these two, what will you get? 3 plus 7, you will get 10 divided by root of 59. So 10 divided by root 59 will be the answer. Is everyone clear with what I did? So when you have this kind of a problem, right? First find B1 cross B2, then find magnitude of B1 cross B2, then find A2 minus A1, then take all those things and substitute it in the formula in the numerator and denominator and you will get the answer. That's it. Is it clear, guys?
Yes, sir.
Next one. R vector is equal to I cap plus 2j cap minus 4k cap. R vector is equal to 3i cap plus 3j cap minus 5k cap. Here, this is B vector and this is also B vector. Then what can you say about these two lines? They are
Parallel.
parallel. Plus 3j cap plus 6k cap. Now, B vector dot B vector cross A2 vector minus A1 vector divided by magnitude of B vector is what is the formula? So what is A2 vector minus A1 vector? 2i cap plus j cap minus k cap. Correct? So what is B cross of this thing? So can you do the cross product and tell me what is the answer? It is IJK 23621 minus 1. Make it fast.
Minus 9i cap plus 14j cap minus 4k cap.
Minus
Yes,
9i cap
sir.
minus 9 minus 14
Plus 14
plus 14 minus
minus 4k cap.
minus 4. Okay. Divided by square root of, so magnitude of B cap is how much? Square root of 4 plus 9 plus 36. So 49, that is going to be 7 in the denominator. Right. But this already has a magnitude. So what is going to be the magnitude of numerator? Square root of 9 square plus 14 square plus 4 square, the whole divided by 7. That will be the answer. So square root of 293 divided by 7 is the answer. Those many, if you want, you can write this also, those many units. Okay. Now, so tell me one thing, will you guys be able to solve these problems if I give you hints?
Yes, sir.
Okay. First one, show that the three lines with direction cosines are mutually perpendicular. So what am I supposed to do? Find L1, L2 plus M1, M2 plus N1, N2, and if it comes out to be 0, then they are mutually perpendicular. So this is L1, M1, N1, L2, M2, N2, L3, M3, N3. So find between all the parameters and then you will get the answer. Next, show that the line through the points is perpendicular to the line through these 2 points. So what are we supposed to do? Find. Remember one thing, okay? Whenever 2 points are given to you, indirectly they are giving you the direction ratio of that line. How? When 2 points are given to you, they have given you the direction ratio. So how you find the direction ratio? 2, x2 minus x1, y2 minus y1, and z2 minus z1. So what is the direction ratio of this line? 2,
2,
5,
3.
3 of 5,
Yes.
2, 5 minus 4.
2, 5 minus 4. Then what are the direction ratios of this line?
3, 2, 4. Sir.
3, 2, 4.
4.
Yes.
So if you know the direction ratios of 2 lines, then how will you prove that they are perpendicular? I showed you the
L1,
formula.
L2 plus M1, M2 plus
A1, A2 plus B1, B2 plus C1, C2 should be equal to 0. Same is the logic for the third one. Show that the line through these 2 points is parallel to the line through these 2 points. If they are parallel, what is the relation between the direction ratios? A1 by A2 is equal to B1 by B2 is equal to C1 by C. Correct? So I will do it immediately. For example, let me come to the second problem. Second problem, the 2 into 3, 6, plus 5 into 2, 10, plus 4 into minus 4 is minus 16. 6 plus 10 is 16, minus 16 is 0. So that is why in the second problem, they are, what do you say, perpendicular. Third one, tell me the direction ratio of first line. Minus 2.
Minus 2, minus 4.
Minus 4.
Minus 4.
Direction ratios of L2 2, 4, 4. So minus 2, minus 4, minus 4, 2, 4, 4. They are in the ratio of minus 1. So minus 2 by 2 is the same as minus 4 by 4 is the same as the minus 4 by 4. Are they not in the same ratio? Hence they are parallel. Or they can say collinear also. Fourth one. Find the equation of the line passing through the point and parallel to this. So when they say equation of line, I would suggest you to write both vector and Cartesian form in the example, depending on marks. If there's a 2-mark question also, I suggest you to write it. Okay. So what is the formula, guys? R vector is equal to A vector plus lambda times B vector. What is A vector? I cap plus 2j cap plus 3k cap plus lambda times B vector is this thing. Correct? So similarly, you can do 5th one, 6th one, 7th one, all these things you can do. We have already discussed. Find the vector in the 8th one also you can do because it's the equation of line passing through 2 points. 9th one also you can do Cartesian form for lines passing through 2 points. 10th one you can do or not? Tell me. Find the angle between the following pair of lines. Will you be able to do it? So what do you do? Cos theta is equal. Tell me for the first one, magnitude of this is B1 vector, this is B2 vector. Magnitude of B1 vector dot B2 vector. Abhina, 3 plus 4 plus 12 divided by square root of 9 plus 4 plus 36 is 9. Square root of 49, that is 7 into 1 plus 4 plus 4, that is 9. So that is 3. 12 plus 4, 16. So it will be 19 divided by 21. So theta is equal to cos inverse of 19 divided by 21. Okay. Similarly, 11th one, you guys can do it. This is A1, B1, C1, A2, B2, C2. You know the formula, do it. 12th one, how to do, guys? find the value of P so that the lines are perpendicular, are at right angles. So this is A1, B1, C1, A2, B2, C2. If they are perpendicular, then what is the condition? 9P plus 2P plus 10 should be equal to 0. So 11P should be equal to 10, P should be equal to, 11P plus 10 should be equal to 0, and P should be equal to minus 10 divided by 10. Right? So remaining problems also you can do. Right? So you can try all these problems, and the next class I'll complete plane. Okay. So plane also I'll be teaching in detail only. I want to know one thing: probability. How depth you want me to go in? Like you want me to do only problems, or you want me to teach the concepts also?
So 13.4 concept, can you explain?
Which one?
13.4, exercise 13.4.
13.4.
Yes, sir.
That is probably this. I think it is probability distribution, right? Random variables and all those.
Yes, sir. Yes, sir. Random variable.
That's the thing you're asking. Okay. That one alone. Other things you are clear. The Bayes theorem and all those things are clear.
Yes, sir.
Conditional probability.
Sir, can you explain Bayes theorem?
Okay, not now. I'm just asking to prepare myself on what I should teach. Okay.
Yes.
I'll do that. So first I have to complete this plane. I'm just calculating how many classes I need. We'll have a class tomorrow. Okay. So that I can come by this week, we can complete this chapter. Then what I will try to do is on Friday and Saturday, I'll give you the video lectures of probability chapter. You go through it. I'm not saying I'm not going to teach. You go through them and come to the class so that we can solve more problems. Okay. So that I can save time.
Next week exams are starting.
I know. That is the reason I'm saying. Because I can't complete it before next week and all. Or one possibility is you have to sacrifice on probability chapter if you don't know. That's it. Other chapters at least try to master them. So one thing that I can do from my side is give you the recordings. You just have to go through the concepts where you have doubts alone. Last year, I think fourth exercise was not there. So I will not have recordings. That alone I have to teach. Okay. So let's see what best can be done. So tomorrow we'll have a class at 5. And we'll have 1 hour session where I'll complete the plane part as well. Just give me a second. 11 points. So tomorrow we'll be done with this chapter. Okay. So any other doubt?
No.
No doubt, sir.
Okay. See you tomorrow.
Thank you,
sir.
sir.